All right, hey everyone, and welcome back. Last time, we looked at a bunch of different programming languages, but today we're going a level deeper. We're going to follow a single line of code on its amazing journey from just words on a screen to an actual running program. We're going to find out what really happens when you hit run.
And the best way to think about this whole process is with this one simple idea. Writing code, that's like being an architect and drawing a blueprint. It's the plan, the design. But running that code, oh, that's the whole construction project, from laying the foundation all the way to the grand opening.
So, let's get our hard hats on and start our first construction project.
Our first build is going to be a massive skyscraper. This represents a method called compilation. And for this job, we're using C++, and our construction firm is GCC, which is one of the most famous compilers on the planet. This is going to be a serious, careful engineering project. Yeah, just like a real skyscraper, you don't just snap your fingers and it appears. There are steps. It's a very deliberate four-step process. First, you gotta have the blueprint. Then, you manufacture all the parts. Then you assemble everything. And only then do you get to have the grand opening.
So, step one, here's our blueprint. It's a simple text file we're calling main.cpp. But you have to remember, right now, that's all it is, just text. It can't do anything by itself, any more than a paper blueprint can actually shelter you from the rain.
Okay, time to bring in the pros. Our construction company, GCC. We give it this one command and watch closely. Boom. A totally new file just appeared, main.o. The construction has officially started.
So what in the world is this main.o file? Well, it's what we call an object file. Our text blueprint has been translated into the raw language the computer's processor actually understands. But, and this is a big but, it's not a complete program yet. Think of it like this. All the floors of our skyscraper have been built and delivered to the construction site. They're ready, but they're just sitting there. They aren't connected to each other, and there's definitely no plumbing or elevators installed yet.
So for that final assembly, we need a specialist. This is where the linker comes in. The linker is basically the project foreman. Its job is to take our custom-built part, main.o, and connect it to all the standard off-the-shelf stuff. You know, the plumbing, the electrical, the elevators. In our code, that's the IOStream library that lets us print things to the screen. The linker wires everything together into one solid working building. And now, the moment we've been waiting for. The grand opening. We run our new finished file, Heldium Tower, and there it is. Heldium Skyscraper is open. It took a few steps, sure, but the result is a super fast, super efficient program that can run all by itself. Okay, building a skyscraper is cool and all, but it was a process, right? What if we want to build something right now, instantly? Well, let's check out our second method, interpretation. If C++ was a skyscraper, think of Python as a box of magic Legos that pretty much assemble themselves.
And you can see the difference right away. Look at the blueprint for this. It's so much simpler. It's just a file called main.py with one single instruction inside.
So with this method, there's no big construction company, no separate steps. Instead, we have this kind of a magic robot that's always with us. This is the Python interpreter. We just show it our instructions. It reads the first line, does what it says. Reads the next line, does what it says. On the spot. No waiting, no object files, no linking. It's immediate. So this is the big trade-off. The skyscraper method, compilation, is a whole process, but you end up with a wicked fast program. The magic Lego method, interpretation, is super flexible and you get going instantly, but because it's translating as it goes, it can be a bit slower when it's actually run.
So it sounds like you have to make a choice, right? Do you want the raw power and speed of the skyscraper or the fast, easy flexibility of the Legos? Well, what if I told you that you don't always have to choose? Modern programming has found a really clever way to get the best of both.
Do we really have to pick one, speed or flexibility? The answer, more and more often these days, is no. There is a third path.
And that third path is called just-in-time compilation, or JIT for short. Now imagine our magic Lego robot is also secretly a genius. It starts by building things one piece at a time, just like before, but it's also watching you,
And if it notices you building the same little car over and over again, it says, aha, I see a pattern here, and it just instantly creates a perfectly optimized pre-built car for you. That's what JIT compilers do. They start out flexible by interpreting, but they watch for code that gets used a lot and compile just that part into super fast machine code on the fly.
Okay, so let's zoom out. Why does this journey, these different methods, even matter? Well, it all comes down to understanding the 3 different paths our code can take to come to life.
So, we had the Skyscraper path, that careful, multi-step engineering that gives you a rock-solid, incredibly fast program. Then we had the magic Lego path, creative and on the fly, giving you immediate results and flexibility. And finally, we met the smart robot, the Jedi compiler, that watches and adapts, trying to give us the best of both worlds.
But this whole conversation leaves one massive final question. Once our program is built, whether it's a skyscraper or made of Legos, who actually gives it a piece of land? I mean, a piece of memory to exist in? Who gives it permission to use the processor? Who is the powerful mayor of this entire digital city managing all the resources? Well, in our next explainer, we're going to meet that all-powerful manager, the operating system. So stay creative and stay curious.